Hello. Hello. A little late on the board. Hello, hello. I'm a little late on the board here again. Give me 1 second. Sorry. 1 second. Hello, hello. Good afternoon. Okay, good afternoon. Good afternoon. Um, 1 second. Good afternoon. Okay. Okay. Hello. Oh, hello, hello. Wait, how'd that just happen? Okay. Good afternoon. Good afternoon. Good afternoon. Hello, Annie. Hello. Good afternoon, Annie. Oh, there's a lot of people in the chat. Okay, I'm gonna wait. So good afternoon, Annie. Good afternoon, Kaya. Good afternoon, Chastity. Good afternoon, Vanita. Good afternoon, Skylar. That is visual afternoons. Now, where's the chat? Chat. Good afternoon, Vanita. That's a double. Good afternoon, Brian. Good afternoon, Kaya. Good afternoon, Sydney. Good afternoon, Chastity. That's a double. Good afternoon, Gabriella. Good afternoon, Natalie. Good afternoon, Genesis. Good afternoon, Brandon, with exclamation points. Good afternoon, Carlos. Good afternoon, Annie. Good afternoon, Mariam. All right. I think that covers. Yes. Okay. Let's. Yes. Okay. So, why? Well, all right. I'll try. All right. So I want to get to we're in the middle of math homework. We're in the middle of homework number two, which is math methods. We are, by the time you really feel like it's repetitive, and by the time, well, you may feel that right away. You'll know that you see what we're doing if by the time you open homework three, if you're like, oh, wait, this is not that big of a deal after all of my work in homework two, then you know what's going on. Now, that might not happen yet. You might still open homework three and think, and I know we're not done by any means going through homework two, but it we're trying to unpack something that once you get it, then you get it. And then it's one thing. But until that time, it seems like a lot of unrelated details. So, and so one way to try to quickly recap where we've been without me really going into a rabbit hole is I'll just say this. If you see how this page, if you see how this page and this page and this page are really all saying the same thing, then you definitely get something. I'm gonna say I'm gonna flip slower in a second. But in fact, going backwards is even better. Like the topic right now to everybody, the physical topic is simple harmonic oscillation. Oscillation means any system that's going back and forth and back and forth, cycling in some periodic way. That's oscillation in general. We are fully focused now on harmonic oscillation, which is a specific type of oscillation, a very regular, predictable oscillation. More specifically, an oscillation that cycles at a rate that is so constant we can predict the rate even before we set up the oscillator. Should I say that again? I mean, really, like that's one English way of putting it. I'm going to say that again. Okay. Harmonic oscillation is oscillation that occurs at a cycling rate, a rate of cycles per second that occurs at a cycling rate that is so constant we could predict and rely on the cycling rate before we even set up the oscillating system, before we even configure it, before we even know the initial conditions for it. Put another, well, yeah, I mean, a much broader way to put, and obviously, again, like stop me in the chat if you hear something that you think is like worth writing down that I didn't write down, but you don't catch it the third time, just tell me in the chat. I need that one more time. It'll make me feel like I'm saying something of value. Believe me. But until I see that, I'm going to say it a different way. I'm going to say that physically, what we're studying now is any system that cycles, that any kind of motion that is periodic, cyclical, in precisely the same fashion as an mass on an ideal spring is. So we're really focused on this mass spring system because it's the prototype for a whole bunch of other systems in nature, in the lab, in micro and in macroscopic contexts. We're looking at all these kind of systems, whether it's a mass on a spring or a bob on a pendulum string or a current going through a certain kind of electrical circuit or a temperature in a weather system. All of these systems behave in an identical, precise mathematical way. And the mathematical way is that they go back and forth. They complete a certain number of cycles per second that is so fixed that we can know it before we can know how frequently these systems oscillate in time without even knowing how widely or how they are set up in space. More, the technical way to put that is to be a harmonic oscillator is to oscillate with a frequency that is independent of amplitude. I'll say it one more time. To be a harmonic oscillator is to be an oscillator that has a frequency independent of amplitude. To be even more concrete, I'm saying the mass on the spring makes a certain number of cycles back and forth. I mean, it makes a certain number of radians every second, and there's 2 pi radians per every cycle. So the mass on the spring goes back and forth and makes a certain number of cycles per second, or takes a certain number of seconds to do each cycle, all the same idea. It makes a certain number of cycles per every second, and that number of cycles has nothing to do with whether x naught is 15 centimeters from the equilibrium position or 20 centimeters from the equilibrium position or 5 or 30. It doesn't matter how far out you pull the mass initially. It only matters how heavy the mass is and how stiff the spring is. That's an example. But the larger point we're making is that the rate of oscillation oscillation just means any kind of oscillation, but if it's harmonic oscillation, which is what we're studying now, then that means the rate of oscillation is a constant, and the constant falls right out of the differential equation. And that's what these different pages are trying to say right here. Like when we were specifically talking about the mass on the spring and the constants in the differential equation were k over m, then the angular frequency omega was the square root of k over m, right? You see, right? And if there was something else, like in the lab, were a pendulum, and the constants in the differential equation were like g over L, like lowercase g over the length of the string, then the angular frequency of the pendulum would be the square root of g over L. Or if the constant is just something that you just some number that you like in homework 3, some number like 121 or whatever. There's a big pro tip here, hint for like all of homework 3. If it's just some number, then the angular frequency of the oscillation is the square root of that number. Like this is a big part of the takeaway we're saying. Okay, and so I'm just looking in the chat. Okay, and I'm letting people in. And you might say, well, hopefully you are saying, like, okay, okay. So, and notice each one of those times, whether I say the square root of k over m, or I say the square root of g over l, or I say the square root of some random number 121, each time, what I'm not making any reference to is the value of x naught or z naught or whatever, or theta naught, whatever the variable is. It doesn't matter what the initial value of that variable is. Omega is omega is omega. That is the nature of harmonic oscillation. Um, and then you might. So I'm saying, what is the rate at which a harmonic oscillator oscillates? The rate is the square root of the constant in the differential equation that describes the oscillator. Then you might say, well, wait, well, like, what if there isn't a constant in the differential equation? Or like, what if there isn't a differential equation to describe the oscillator? But the converse of everything I'm saying is this: to be to be a harmonic oscillator is to be a system that is described by that differential equation, the differential equation that we are studying this month or for all of this time. Okay. Partly it's our introduction to differential equations, so that's why we're taking so much time in, but it's just one. I mean, there's many differential equations in the world, but this one is a big and important one. And I'm almost, again, technically right now, where am I? What am I doing? I'm technically just like reviewing, recapping, which I sort of feel like I have to do every time because the class schedule is so spotty right now. Um, so I'm just like in space reviewing for a moment. In English, a harmonic oscillator is any system that behaves precisely like a mass on an ideal spring. Physically, that's what a harmonic oscillator is. Mathematically, a harmonic oscillator is any system that can be described by this differential equation. And when I say this differential equation, I want you to notice that almost every time we have class, I might write it slightly differently. Like at the top of the page here, I'm going fast on purpose. I'll slow down first in a second. But like I'm trying to show you that I'm writing the exact same differential equation on the top of the page each time. But if you look at it closely, it's not exactly the same. Every time I'm going to write it slightly differently, not because I'm trying to confuse you, but because I'm trying to train you into realizing that some details don't matter and only some details do. Just like you already know, it doesn't matter if I write the equation in yellow or black, right? And it doesn't matter if we write it in my handwriting or yours, it still is the same equation. Well, similarly, it doesn't matter if I call the dependent variable x or theta or z or whatever. And it also doesn't matter, sorry, and it also doesn't matter what I call that constant in there. I could just call it the word constant. I could call it a number. I could call it k over m, which is a constant divided by a constant. That's a constant, right? Or I could call it g over l, or what, or I could call it omega squared. No matter, but there's definitely a constant there. Because what we're really saying is the nature of a simple harmonic oscillator is a system, an object, I think, is a dependent variable, is some kind of measurable quantity that depends on time and depends on time in this way. What way? This way. The way is that if the rate of change of that variable with respect to time is directly proportional to the variable itself, negatively, then it's a simple harmonic oscillator. That is a mouthful, but it's not gobbledygook. I'm going to say it one more time the exact same way. Like I'm saying in English, if you can measure something, if you can measure either length or arc length or electrical current or temperature, if you can measure something and you find that the rate at which that quantity changes the rate at which that quantity changes in time, if you find that the rate of the rate, i.e., the second derivative, is directly proportional to the quantity itself with a negative sign, then that means that variable, that measurement is in effect following Hooke's law. It's always being, and this is where the negative sign comes in, it's always being restored back to some equilibrium value, and the rate at which it's always being restored back, the rate at which it's always accelerating back to an equilibrium value, that rate is directly proportional to the value that it has at that moment. That's what we're saying always. That's what Hooke's law means. And we're generalizing Hooke's law to all these different systems. So, and I'm almost done, I promise. What if we say something is directly proportional to something else? If I say y is directly proportional to x, like it doesn't mean, and I'm not condescending. I know you know this, but you might not have. I mean, it took me a while that if you say that y is directly proportional to x, that doesn't mean that y is equal to x. Like, of course, I mean, it's not the same word. If you say that y is directly proportional to x, you don't mean that y equals x. You mean that y changes in the same way that x does, right? You mean that if x gets doubled, y will get doubled. Or if x gets tripled, y will get tripled. It doesn't mean they're equal. It means they change in the same way. It means if you put them on a graph, you'd have a straight line. The slope might be 1, or it might be -1, or it might be some other thing. But it means that whatever that slope is doesn't change, right? Well, that slope is the constant of proportionality, right? One thing I never realized until I did is that to say that y is directly proportional to x is to say that y equals some constant times x. That's what it means. If you say y, and you might want to write that down if we say that y is directly proportional to x, we're saying y equals some constant times x. So I'm telling you that the differential equation that we are studying right now, I mean, it looks like a mouthful, but really we're saying that something could be graphed onto a straight line with something else. It's just that the first something happens to be a second derivative. We're saying second time derivative. If a measurement is oscillating harmonically in time, then the second time derivative of that measurement is directly proportional to the measurement itself. If it's directly proportional to the measurement itself, that means it's equal to the measurement itself times a constant. Now, what we're finding here, what we've done all this work to find out is, if that's the case, if a system can be described by that differential equation, then that means what this page says. It means that that measurement of that system is oscillating harmonically. It's going back and forth and back and forth in the manner of a cosine. Like necessarily, if the system can be described by that differential equation, then the variable is oscillating harmonically. And bottom line, now landing the plane, hopefully, the revelation that we had to do like weird, like retrofitting, like reverse engineering to figure out. But not only can we say, aha, if something z is described by that differential equation, then z is oscillating cosinusoidally. Sorry, I just lost my train of thought. Then z is oscillating cosinusoidally at a rate which is necessarily the square root of whatever the constant is in the differential equation. And there has to be a constant in the differential equation. Otherwise, literally, it would not be that differential equation. Like that, okay? So the form of the differential equation is second time derivative of variable equals negative times constant times variable. That's whatever you call the variables and whatever you call the constants. That's what we're saying. That is what we're saying. And we are, by the way, the one thing that we are definitely like believing throughout all of this is that the dependent variable could be whatever. That's why sometimes I call it z, sometimes I call it x, theta, but the independent variable is definitely time. Otherwise, this wouldn't be physics. The independent variable is time. So I'm gonna last thing, and I'm gonna again. In principle, this is review or like clarification. For some of you, it might just be making matters worse. Who knows? Whatever. But the one last thing. But this is why I just want to clarify why a lot of times now when I write the equation in general, like on this page, why I write d2z equals dt squared equals negative omega squared z. I don't want, please understand that omega is a constant. So this is not like a quadratic equation. I'm not saying that any variable is being squared. Omega squared. Omega is a constant. So omega squared is some constant. Omega squared is just a number. The reason I write it as omega squared is benefit of hindsight, the reason we write it as omega squared is because our big revelation that it took us this long to figure out is that omega, like the angular frequency of the oscillator, is going to be the square root of whatever we write in those parentheses. That's what I'm trying to say. I mean, for example, when what's in those parentheses is k over m, then the omega is the square root of k over m. So we just say in general, whatever that constant is definitely going to be the square of whatever we find out the angular frequency to be. So that's why we write it that way. It's like now that we get it, we put it all in one general package that way. Hopefully that, like literally, if you get that this page is saying exactly the same thing as this page, then you get it. And if you don't, that's okay, but you should let me know, or you should think about it for a while and then let me know. I'm looking at the chat. Okay. But all right, that's where we are right now. That is where we are right now. We have to go back and keep doing, practicing this with homework too. We have to go back and practice, but before we, well, wait, let me just, I mean, I'm almost afraid. I know most of you are, I think we've already mentioned, many of you, if not most of you, are at the stage already where you're like, I think I get what you're saying, but what I really need is to see this in action or in practice. I need more practice. So yes, I mean, if that's where you are, like you're right, and that's cool. So I will get back to the grind of the practice of homework two and everything. However, there's something I have to do before we do that. But are there any questions at the moment? Like I don't want to. Like, I'm going to shift gears before I do that. So if before I shift gears, because we finally have a full week, so I can afford to shift gears. Are there are there any questions? Okay. I mean, you can stop it. So here's the deal. This is the point of the semester. We've gotten just deep enough. Like, I mean, in a way, of course, I hate to break our momentum, but we've gotten just deep enough into the abstract mathematical description of a seemingly obscure topic, which is a mass going back and forth on a spring. Like we've gotten just far enough to see that this seemingly simple situation is going to lead to some abstract mathematical thinking. So now that you've gotten a flavor of, and it's going to continue like that. I mean, we're going to continue, and the math will get more abstract, not less. So this is the time in the semester for me to pause before we go any further and say, now that we've gotten a flavor for what Physics 204 kind of looks like, the question is why? Like, why really do we care about any of this? Or put more specifically, the question is, what is it that Physics 204 is doing for us that Physics 203 didn't? Like, if it's the same, it is the same principles and practices. Like, we are still ultimately here to learn how stuff moves through space and time. That is it. Kilograms in meters and seconds. That is physics forever. Where will something be when? Or where was something when? That is all of physics, no matter what class code it is, honestly, or what topic, or what century. So the question is kind of like, why do we need more than one physics class? Or what's different about this one from the last one? Is it just that the calculus gets harder? The calculus does get harder, but why does it get here? The answer is ultimately what I'm looking for ultimately in the UnthingyThings sheet, which I did assign, which you did get credit for, which you were asked to do. And the purpose of it is to make clear what the purpose of this whole course is. So I want to deal with that today. Whether for some of you, it'll be a nice change of pace because it's more of a discussion. For some of you, it'll be like totally um, um, jostling, and I apologize for that. But I'm going to shift now gears into a discussion topic. And so we're not going to do any more math today. We're going to get back to the math tomorrow, Wednesday. But for the moment, I'm going to shift screens and remind you what I'm talking about. I mean, I'm talking about life. Wait, sorry. I'm talking about, yes, I'm talking about. Okay, talking about this sheet, which was assigned, which if you did it at all and you did it on a separate document and you got full points for it, I asked you to think. I asked you to take two objects, hold them in front of you, and then try to perform a set of tasks with these two objects. And some of them were possible, and they were so possible that they were really easy. Wait, why is Annie? Wait, sorry. Wait, is there, do you choose? Wait, you're here. I know you're here, but on my device, it's saying, hold on, sorry. I feel like two.
Yes, I'm also using my phone to join this
Oh, sorry.
class just for today because my headphones connect to my phone.
Oh, that's totally fine. All right, sorry. I just thought I was going. Okay, so I need to, but why isn't? Okay, sure. Hold on one sec. Uh, sorry. I only has, oh, but it's only in. That's weird. This may not work because it's about to admit you to the board. Not well. Let's see. This. Tell me if it doesn't work. Um, because somehow only my board knew that, not my computer. But because I have two devices too, obviously. But did it work? Well, okay. Is it there? Well, no, it's not there. Maybe because I think try, somehow it was communicating to the co-host, not the host. Try to the host. I don't know. Is that a difference? But that's not a difference, is it? I don't even get. Um, uh, I don't know what to hold on, say. Uh, well, I'm just gonna go on until you okay, I'm just gonna but all right, to everybody that'll get worked out. But to everybody else until that gets worked out, um, 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 right, this was the sheet. And I asked you to do these tasks, right? And I asked you to do them with two objects. And we're going to discuss this now. Like hopefully you remember your answers. I mean, or you can rethink it now and then probably your answers won't change too much. But the one thing to just sort of bear in mind is I'm asking you to pick any two, and it's not about right or well, it is ultimately about right or wrong answers, but I asked you to pick two objects, and but I just asked you to do sort of the physics thing of focusing your attention for each object on a point, like a pixel that represents the whole, right? And similarly, think of space and time in that way. So if we talk about objects being in the same space, we mean literally like the same coordinates on an X, Y, Z axis. If we talk about time, we're talking about like literally the same instant, right? I mean, you're used to this from physics 203. We're talking about in the limit, in other words. And but same thing with the physical mass now, too. If you talk about a pen, like you hold up the pen so that you can picture it, but we're asking you to sort of picture a pixel at the center of the pen that represents the whole object, right? And with that in mind, that's why it says like TCPO every 5 minutes in the sheet. Um, so with that in mind, and assuming this is the sheet, I'm going to go through the tasks. I'm going to ask you. We're going to go like have a quick discussion or something. We're getting your feedback on them. But the goal is by 420 for me to not only tell you what I think the answers are, but also to tell you what the point is. Like ultimately, the point of this sheet is to try to make clear what the point of physics 204 is. I mean, there is a point, in other words. It's not just like a fun thing. Hopefully it's fun. So I'm going to stop the share unless you need it, unless someone needs it. Stop the share. Be selfish. Okay. And I'm now going to so I'm going to take votes of all of you. I'm going to ask you questions. Or, no, I'm stopping that share, but I'm not stopping the whole share. Sorry. I'm going to ask you each one, like whether you said possible or impossible. So, so, oh, that's okay. So, like, I'm going to ask you what way you voted, for example, on this one. I'm going to ask you, did you vote possible or impossible? And I'm really going to ask you all, I mean, this is a class, right? So I don't care which way you vote. I don't care if you're wrong. I mean, if we could generate cool discussion, that's all the better. But I want you to vote. I want you to make a commitment each time, even if quark forbid somehow you didn't do this homework sheet. You could think of it right now. You have the sheet in front of you, or you screen share, whatever, or you screenshotted it. I want everybody to vote each time. So, as a test, as a base case, or as the control of the experiment, before we start the voting, I'm going to ask you right now if you hear my voice at all, if you are part of this class, could you please raise your electronic hand and keep it up? Awesome. Thank you. Thank you. That's good. Or your physical hand. I got, yeah. Oh, even better. Okay. Oh, yeah. It doesn't. Great. Keep him up. Keep him up. Let's get everybody. And he is joined. Okay. Everybody, though, please, if you hear me at all, just raise your hand. Even if you're totally not, if you're just paying attention enough to hear me, could you please raise your electronic hand and keep it up so I can feel you? Thank you. We're almost all there. And I understand some people have two devices, fine. But there's three more people. Like, I'm not trying to, I'm just saying, hello, Genesis. Hello, Carlos. Hello, Miriam. With all due respect, if you're there, if you could raise your hands. And if not, okay, well, we're all okay. Thank you, thank you, thank you. Awesome, awesome. And Miriam and Genesis, if you're there, if you could, and Miriam. Okay, so, but can you practice raising your hand just because we're going to do votes? Great. That's a way. Oh, great, great. Oh, like, okay, I'll take it. Right. Great. So, okay, Genesis, that's awesome. Okay, we're almost there. Genesis, can I just get a hand from you, Genesis? Just, I'm not trying. Great. Or no, that was wait. Genesis, can I get a hand from you if you're all right? Well. If someone's in their house, okay. All right. So that's a total. So keep them up for a minute. So the total is 9, 12, 15, 16, 17. Okay. So the population, the voting population is 17, right? Unless I'm wrong. I mean, because somebody has two devices and someone's not here. Okay. So 17. Now you can put your hands down. Now I'm hoping on every vote we take to get a total of 17. This is not the United States. This is not a presidential election. Like the right to vote does not mean the right not to vote here. This is not Florida. All respect to Florida. Like, right? You got to take a position one way or the other because it's science. Okay. And Gab, and so, oh, cool. Okay, thank you, Direct Chat. Oh, and thank you. Great. Oh, you're always so much faster than the other class. Not that it's a competition, but it totally is. Okay, so on the first one, on task number one, my first question is, if you voted yes, this is task one, right? Two mass points at two space points at one time point. If you if you voted yes, this is possible. I mean, if you decided yes, this is possible, please raise your electronic hand right now. Awesome. And keep it up. I mean, keep them up. Awesome. Thank you, Brian. Thank you, Chastity. Thank you, Skylar. Thank you, Natalie. Thank you, Andy. Thank you, Carlos. Thank you, Gabriella. Thank you, Brandon. Thank you, Vanita. Thank you, Sydney. Thank you, Samantha. Thank you, Yaneli. Thank you, Kaya. Thank you, Miriam. Oh, this is good. It's good. Now, again, not this comparison, but you guys are definitely, boy, the morning class. Whoo. Just today, I mean, in general, I love them like I love the morning class. But okay, so pretty much you all voted, and I think Genesis is not with us. So you all right, great. So you all said it's possible. So maybe there's not even much to discuss. Terrific. And by the way, you can put your hands down now. Thank you. But and like anything else, I promise this is not a trick. I'm not trying to trick you, and I'm not trying to waste your time. If I'm asking you questions that seem simple, good, but presumably there's ultimately a reason that presumably I'm ultimately going to contrast them with something else or something like trust me, right? So there wasn't meant to be a trick here. If you all thought it was possible, that's great. I'm going to go one step further and you can put your hands down unless you have a question. I'm going to go one step further and ask, is there anybody there? Maybe even someone who doesn't normally, but is there anybody there that wants to turn on their video for just a second and do a little demonstration with their hands? And it's not a trick. Whatever you think is the totally obvious thing is what I'm looking for. I promise. I'm ultimately trying to make a point. So if anybody feels like turning on the video for a moment and just showing how to do task one, I would greatly appreciate it. And if you could do it with an animated avatar, that'd be like super cool. I'm not sure if that's possible, but is and I'll tell you right now, we have five tasks. So whoever goes now, even if it's an obvious person, it's going to be a different person each time. So, okay. So Annie, okay. I mean, video killed the radio star. I'm just saying. So, and no, terrific. Annie, show us, please. And here she goes. Okay. It's coming.
Wait, let me see if I can find like a prop.
Okay. Oh my God. And it's so spooky because her voice is coming out of the other device, as she said. So it's, actually, she's almost just literally proving one of these with the audio. All right, whatever. All right. Okay, here it goes. Here we go. Okay.
So, can you guys hear me?
Yeah, yes. Or that I can anyway.
Okay, so like if my palm is like the table, then
Okay.
I have like one object here and then like the other one here. So
Okay. Perfect. That's all. That is great. So she is just, and I'm not trying to be weird. I mean, I'm trying to be a little bit, but as far as I'm concerned, and remember, we weren't proving that we weren't asking whether these things always have to happen. We're just asking whether they're possible. And I do believe that Annie is just sufficiently, excuse me, showed us that this task number one is possible. It is possible to have two mass points occupy two space points at one time point. Very nice. Thank you very much. And I'm not being sarcastic. I'm just being silly, but it's true, right? Now, that's task number one. So there we are. Okay, now we go to task number two. I'm going to ask the same question again. Is raise your hand if you say that this one is possible. Oh, and what is this? This is two mass points at two time points at one space point. Okay, Chastity, yes, thank you. Kaya, thank you. Sydney, thank you. Natalie, thank you. Is that so? This one, I'm just looking at the chat. Okay, right. So, and by the way, yeah, this is a different task. I mean, it's all the same words, but the words are definitely being put in different places. So this is a different task. So I'm going to say again, and keep your hands up if you're saying possible. This is two mass points, two time points, one space point. We're asking, is it possible? And so far we have Chastity. Well, I don't want to name it. Well, yes, I do. We have four people saying it's possible so far. Chastity, Kaya, Sydney, Natalie. Is anybody else? Is anybody else want to say this is possible? Oh, and Annie. Anybody else want to say this is possible? Oh, suddenly it's Brandon. Not don't succumb to peer pressure or anything. I mean, well, whatever. Okay, Brandon, awesome. So going what Skylar? I wonder what's happening. Oh, Gabriella. It's the crew from last semester. Okay. For all I know, they're okay. Anybody else going once? But wasn't Genesis in that crew? Okay, whatever. And Samantha? Okay, anyway. Going once, so we're keeping our hands up if we're saying it's possible, but going once, going twice. Okay, put your hands down. That was eight. So eight said it was possible. And yeah, you could put your hands down. Or wait, oh, someone just added? Did Miriam just add maybe? Okay, maybe that was an adding, so it's nine, but okay, but you can still put your hands down. You could put your hands down, unless you have a question, or you could put your hands. Okay, thank you. So now wait, so now I'm going to ask because it seems a little different this time. Raise your hand if you say this one is impossible. This one, two mass points, two. Okay, Carlos, Brian, thank you. That's two. We still the total. Remember, the total is it's 9, 12, 15, 17, right? The total is 17. No, the total is 15. The total is 15. So we had nine for yes. We have two for no, but some people still have not voted. We're asking, is this one possible? Two mass points, two time points, one space point. Now, again, I got to urge you guys, like, not to be, I may be being silly. And yeah, I think this is simple. I'm not saying it's easy, but I am saying it's simple. And it certainly isn't math. I just want everybody to participate. Like, everybody should vote at one point or another. It's not hard. I mean, I should never say that, but compared to some things we do in this class, this is not, I don't care if you're wrong, but we've had like, I think we just said like nine people voted for possible. Two people, thank you very much, are saying impossible. That makes 11. There are some, so okay, so put your hands down. Raise your hand, honestly, if you just raise your hand if you hear me right now, but you did not vote one way or the other on this one. So I'm losing people. Guys, all right, we're going to do this again. Just raise your hand if you hear me right now, period. Raise your hand, your electronic hand, and keep it up if you hear me right now. This is the control of the experiment. Okay, and keep them up. Thank you. Okay, and keep them up. Raise your hand if you hear me right now and keep them up. Thank you. Okay. Wait, so that is literally everybody, even including that's everybody. All right, that's awesome. Thank you. By the way, this counts as participation. You can submit for the points for the fact you just read. But now, if that's everybody, I'm going to do this one more. I'm looking at the clock. I'm not trying to be weird, but like, how can we solve differential equations if we, right? I mean, so that's everybody. So you got to vote for either possible or impossible, or put something in the chat. Oh, you forgot. Oh, I was just going to say, or put something in the chat to let me know what's going on. Okay, which some of you are doing privately or publicly. Thank you. That helps. We're going to try this. Well, all right. I'll accept the things that are in the chat to help. And I don't want to like, all right. So put your hands down. I'm not going to redo this vote. I'm going to plead with you on the next vote to be full, all of you. But I will say on this one, oh, yeah, that's actually true. Yeah, yes, I know that the question is, but I mean, is it really? All right, I'll look at it while I'm talking, but I don't want, you know me, I could easily get into a rap, like I could suddenly find that more fascinating than what we're actually doing. I'll look at, yeah, I know you're right, but I'll think about it. But I don't know why that should be any easier on your side. I mean, I guess it is, but um, I'm getting it, but I don't want to get into my reason. But okay. I'm gonna ask this on the second one. We did have some kind of split. Some people voted yes, and some people did vote no, which I appreciate, which does show that something is different here. So I'm going to ask now, is anybody, besides Annie, just because she went on the last one, is there anybody who voted yes? That doesn't mean it's right, but anybody who voted yes on this second one who can show a simple, quick demo, like put your video on for a minute and show a simple, quick demonstration of this second one, um, and show that it's possible. Anybody new, please. I think we can do this. OMG. That stands for Oh My Gravitation. Really? I mean, really? Like, because the awkward thing is, I mean, am I really going to have one student? I mean, we don't really, I mean, do we want to make this all about one? I don't even think that student one. Thank you, Sydney. Awesome. Okay, go for it. Oh, yes. Yes. She's even, see, okay, I'll shut up. That is multiplayer co-op right there, too. Passively, that helps Andy. Okay, go for it, please.
Okay, so I have a pencil, and this is like 1 point, and then a couple seconds later, another pencil, and the same point.
Okay. Ladies and gentlemen, Sydney Cole and Annie Lee. Ladies and gentlemen, see, this is what having to endure Yavrum for more a semester and a half. This is what it brings us to this level of No, thank you. I'm being silly, but I do really appreciate it. And I agree. To be clear, and again, I promise this is going somewhere, and it's not, and it's going somewhere real. I totally agree with what Sydney just did. Also, notice both Annie and Sydney, of course, you apply for points and you used your voice, which I really appreciate. Like, there's a million points you should now get for all of this. I leave it to you to do that. But let me say to everybody too, here's also what's interesting. It's not just that it was two different people, but notice, even though both their answers was yes, possible, and even though all the same words are being used, they did something actually different, right? These are two different tasks. Let's just be clear. 3 plus 5 is 8. This is an example. 3 plus 5 is 8. And also 9 minus 1 is 8. It is the same answer, but to two totally different questions, right? Don't think that just because the answer is the same, the situation's the same. So Annie went like this, or so essentially, Annie went like, well, you can't see. It looks like I'm flipping you off. Sorry. You like, she basically did like this. But then Sydney did something very different. Sydney was like this, and then that. That's different because space and time, they're very similar in many ways. As the rest of the sheet asks you to think about, like to cut to the chase. I mean, space is infinite, time is infinite, or we experience it that way anyway. Space is infinitely divisible, or we experience it that way. Time is infinitely divisible. I mean, in other words, they're both smooth and continuous. Space, space is the same everywhere throughout itself. Time is the same everywhere throughout itself. I mean, they're very, very similar, yet there's something different about them where to have two things at the same space, two things at two different times at one space is not the same situation as two different spaces at one time. So different that I dare say, well, in other words, I'm agreeing with Skylar, and I think it's important that this one's also possible. But those of you who said it was impossible, you're not crazy, and you're not to be ashamed of yourself, and you could submit for the points for like being wrong or whatever. Because if you said that the first one was possible and the second one's impossible, it's because the wording is like throwing you off in a way, or because you're realizing that there is a different situation being asked. I mean, now hopefully, I'm going to look in the chat. I'm going to move on and say, hopefully, now that you see Sydney's, did I say Sydney? Did I say Skylar? I meant Sydney. Yeah, sorry, Sydney. Now that you see, that's what I said the whole time, right? Okay, I'm not even going to look. I'm too embarrassed. Now that you saw the demonstration, hopefully you do see that it is possible. But if you didn't think it was, because you couldn't like parse the words, you're not crazy. It is abstract stuff we're talking about. But I do think it's possible. Okay, I'm looking, wait, I'm just going to look. I'm going to move on a second. Again, this is meant to make a point. I'm just looking at the chat where there's, oh, there is stuff in the chat. Hold on, hold on. Okay. And thank you. Thank you for the people in the private chat that are like apologizing for not being there and stuff. I totally get it. Fine. I'm not trying to. Okay. Cool. Cool. All right. Now, again, I'm promising you that this is actually going somewhere, even though it doesn't feel that way. So we go to task 3. So far, task 1 and task 2 are both possible, but not the same thing. Now we go to task 3. 2 mass points, 1 space point, 1 time point. Again, a different task. So quick question. Raise your hand, your electronic hand, if you say this is possible. I'm going to say it again. Raise your hand if you say this is possible. Interesting. Okay. Okay. I'm going to take that. Okay. Raise your hand if you say this task is impossible. Oh, oh, I found that fascinating. Oh, and it's like almost everybody is back. Oh my God, they finished their cigarette. I'm just kidding. Okay, no, cool. Oh no, I'm psyched. And everybody just wait. And there's like one person, I'm not gonna call attention to anybody. That's good enough for me. So everybody who's voting is voting impossible. Now, clearly, then I can't ask you to prove your point by demonstrating. I mean, you're saying it's impossible. Um, but I agree. Bottom line, I agree. Unless anybody wants to say anything about this, you can't have 2 things at one place at one time. I mean, it sounds like duh. Like, in a way, I know we always knew this. In a way, all of us always knew this. What I venture to suggest is that we didn't always know why it was important or that it was important. And that's what I want to get at. But yeah, I think it's well, right. Unless there's a parallel universe. Also, if you really want to be, yes, I mean, in a parallel, God knows what's going on in the parallel universes. Should I say what's on my mind right now? No, no, inside voice, inside voice. Uh, I was in a relationship once a long time ago, a long, long time. I'm just saying a little too much information. One time I was in a relationship I mean, obviously I'm married now and have children and all that, but a long time ago I was in a relationship and the person I was in the relationship with hated physics and did never wanted me to talk about physics. And I didn't know why until well, I don't know if this was really the reason, but one day she said, all that physics stuff is such crap because I know all you physicists, basically your whole point is just that it's all a big construction so that you can believe in parallel universes and you can have a different woman in every different parallel universe. Just that, which is not, that's what she's, anyway, okay, whatever. So sure, I guess anything could happen in parallel universes. I don't know why I'm talking about that. But to be even more concrete, I will admit, many years, many semesters, sometimes people will really think about this one and come up with some really interesting, like, I'll admit, some years people say things like, wait a minute, what about, couldn't you have the center of like a donut be in the center? Couldn't you dip a donut in your big coffee, your big cup of coffee, right? And couldn't the center, or whatever, couldn't you put a pencil in a cup? And wouldn't the center of the pencil be in the center of the cup, which is interesting, just to acknowledge that people, or whatever, like put a pencil in a donut. And wouldn't the center of the pencil be in the center of the donut hole? People have said things like that in the past, and it's worth discussing. But to cut to the chase there, what I have to say is, yeah, that's really interesting. But even there, the only reason that works, like you can put stuff in containers, but they have to be containers for that to work, i.e., the way to make that work is that you've literally taken mass out of the cup, and made it a hollow cup so that you could put another object in there. And you had to go through all that trouble and in your mind come up with this sort of like really clever example because what we're still recognizing is you can't have a pen in the cup if the cup is solid all the way through. You can't have 2 things literally at the same point at the same time, right? So anyway, even in a parallel universe, well, God knows what, right? Okay, so I'm just saying that's like, oh, Rick and Morty. Oh my God, I love. Okay, we're not talking about that right now, but yes, um, and that guy, that's the same guy, right? From like, yeah, Community, right? Hilarious. Yeah, okay, right. So that's impossible. Now we go to task 4. So that one's impossible. Now we go to task 4. Task 4 starts getting a little bit awkward. The wording is awkward. One mass point at 2 time points at 1 space point. Oh, sorry, Miriam, is that a question or you're raising your hand? Sorry. Or Miriam, is that a past vote that I didn't, or you raising a question? Maybe no. Okay. Um, so task 4. Oh, well, maybe you were just, oh, sorry. Who says task 4? Maybe this is Miriam. Who says task 4 is possible? Okay. Okay. Thank you, Annie. Thank you, Natalie. Thank you, Carlos. Thank you, Genesis. Thank you, Chastity. Thank you, Sydney. Thank you, Brian. Thank you, Samantha. Thank you, Yaneli. Thank you, Brandon. Thank you. Oh, a lot. Oh, thank you, Skylar. Thank you, Miriam. Excellent. Okay, that's a lot of people. Thank you. Um, great. Put your hands down. I mean, that's almost everybody. And who says who? And you can put your hands down. Thank you. Who says thank you? And you can put your hands down. Thank you. Who says uh who says this is impossible? Oh, interesting. Okay, Kaya, thank you. And by the way, awesome. And I could see why. Well, anybody else, sorry. Anybody else say that it's impossible? Okay. Well, I totally appreciate that. Because of Kai, I think everybody has actually voted this time, or just about, which is great. Thank you, Kai. Now, um, and I definitely appreciate that people are willing to vote even if other people don't vote. Like that's important. I mean, this is science. It's not democracy. So great. So thank you. So Kai, you can put your hand down. Now, and this one is the wording is very strange on this one, but it's exactly what it needs to be. Could somebody new, like so not Annie and not Sydney, and not Kaya, because I want to ask somebody who voted, I mean, that's all with respect, somebody who said this was possible. Could somebody new quickly demonstrate the possibility of this? Does anybody want to demonstrate the possibility of one mass point at 2 time points at 1 space point? Or put another way, one mass point at 1 space point at 2 time points. I don't want to put old people. I don't want to have the same person to any. Really? No, really? I mean, if you can figure out how to do it. Well, okay. I'm sort of. Okay. Wait. Pause for a second. I totally believe that you, and I do want. I just want to see if there's any way I can get a new person, but I do appreciate it. Unless you're saying you have a question. Also, it'd be great to see if an animated avatar can do this, but I don't think so. Well, okay, wait. So don't. Or is there anybody before I mean, I'm happy to call on Annie, obviously, but I just feel like it would be better for everybody, including her, if a little variety occurred. Is there anybody, even if you don't want to turn on video, is there anybody who's either willing to just use their voice and describe what they would do or put it in chat? Or you could literally in chat tell Andy what to do if that's what it's going to come to. But is there just show me that you're alive. So, in some way, describe how to do number 4. Come on, really, people? 2 semesters together? I mean, really? I mean, you think it's embarrassing to be you? Can you imagine having to be me? I mean, do you know my neighbors are like, what does this guy do in front of the window all day? Guys, okay. Wait, just somebody at least put something in the chat that just said, even if it's private, that just says, I can't emotionally handle this right now. Something just to acknowledge to me that you hear my plea. OMG. Oh, okay. I see something in chat. Thank God. Wait. Oh. Okay, no. All right. First of all, I just got something in the chat that says, I hear you, but I'm too scared. That's totally honest. I'm not even going to make fun of that. Honestly. And I mean, and then they wrote LOL. So like maybe they're half joking or like what? but like, I'm not going to go down a rabbit hole, and I'm certainly not going to say who the person is, but like, that's honest, that's fair. And can I just also point out again, and I'm just trying to make this light and accessible. I'm not trying to scare anybody, but deep in my heart, I hope you all understand that I view physics class as group therapy for math trauma. Like, really? I mean, in other words, I mean, I'm making all these jokes and stuff to just try to keep it okay for everybody, but I actually do understand that it's scary, and I chose to do it with my life for years. Right? I went to college and graduate school twice for this stuff, and let me tell you, I was petrified most of the time. Just so you know, don't think I don't. I mean, right? I understand. I'm just trying to make, so I'm not ever going to, so even just admitting to me, I don't want to do this because it's too scary. I get it. Now, one funny thing that I've noticed about John Jay, I've come to learn that in some ways, what some of you are more scared of what your peers would think than what I would think, which is also totally fair. And I'm not going to go down but you know, I think your peers are just as scared of you as you are of them, but like, whatever. Okay. So fine. I appreciate the honesty, but I also saw in the chat some descriptions. So, excuse me. Um, Um, I also saw some descriptions in the chat which really helped me. For example, one person wrote, no, okay, and a number of people, no, and I totally appreciate it. A number of people, I hear you, but I get nervous. I can't turn on my camera. I actually totally get it. I am not trying, just as long as you're like with me, which is what you're saying, it's fine. I appreciate it. But then somebody did say in the chat, by the way, you know what the easiest way to get over, I know this is not what you're saying, but like another piece of life advice. One way to get over the fear of a C, I'm not saying this is what you're afraid of, but just as an analogy, the weirdest thing, and I'm not recommending this, but one way to get over the fear of a C is to get a D and find out that you're still alive. One way to get over the fear of a D is to get an F and find out that your parents still love you. One way, etc. Or one way to get over the fear of a B is to get a C and find out you still have a job or whatever it is. Like, no joke. All this stuff hurts a lot less than it actually seems. It's always scarier in your mind than in reality. And I'm telling you that as someone who's had a lot of success that I'm very happy about in many areas, but I have had a lot of failures and they don't hurt as bad as they do as they seem like they're going to in my mind. But anyway, okay. Oh my God, actually, okay, except for Annie's. Okay, fair enough. Fine, fine. I actually fine. But all right, so back to the it's a bad analogy. Uh and make no mistake, if my son gets a B, oh, he's out in the streets in a minute. Let's be clear. That's a joke. But someone said in the chat, okay, this is good. I'll go with this. Someone said, yeah, it was public. Thank you, Carlos. Oh, you get total points. Okay, I mean, he's not the only one, but since he went public, I'll read his thank you. Just hold out an object in the air for 2 seconds without moving it. Oh, wait. I'm gonna back up. This is great. Wait, okay. I'm back on physics now. The ADHD medicine is kicking in. Okay, back to someone in the direct chat, someone said you could take a pencil and place it on a spot on a table. You could take a pencil, place it on a spot on a table. Then a couple of seconds later, well, presumably then remove it, and then a couple of seconds later, put the same pencil in the same spot. Right? So one person said, do this. Right? Right? That's one, and that's totally correct. That totally works. Put something somewhere and then put it there again. That is one mass point at two time points at the same space point. As awkward as that sounds, that's what that is. But then Carlos absolutely correctly said, well, actually, you don't even have to do all that. If you're really like, if you want to really like be physicsy about it, you could just go, because the thing is here now, and it's also here then. Absolutely, both are completely correct. It's just kind of interesting that either one is, that both are correct. Absolutely. So first of all, thank you for sparing us the blah, blah, blah. So that's possible. As awkward. And I like the two creative. So I'm glad we did put that in the chat. And please submit for points. That's task 4. And then finally, task 5, which is the same words, but in a different place. This one's now one mass point, 2 space points, 1 time point. So raise your hand if this is possible. Going once, going twice. Again, raise your hand if this one is possible. Interesting. Okay, going now. Raise your hand if you say this one's impossible. Yes. Oh, yes. Oh, okay. Thank you, Sydney. Thank you, Annie. Thank you, Kaya, Yaneli, Skylar, Carlos, Genesis, Gabriella, Natalie, Brian, Chastity, Brandon, Samantha, Mariam. Thank you. Okay, that's okay. I keep seeing that they will disown. I got to put something else in the chat to overwhelm it. Yes, so you are. So to cut to the chase, you're all saying that one just because the wording is different. I mean, well, just that one is impossible. Now, you can put your hands down now. So I agree. First of all, it's like, what is the point of this? In a way, if you might not have discovered anything new yet. These might be things that you always knew and just didn't care about. Often that is what physics is. What we're saying so far is that things can do like task 1, task 2, and task 4, but they can't do task 3 or task 5. I mean, that's what we're saying so far, right? So what? Well, okay. So later in the sheet, it asks you some questions like what is space? What is time? What's the definition of a particle? The particle is the main ultimate punchline of this. Many of you said things like a particle is like really, really small object. Well, it could be, but it actually doesn't have to be in physics. An electron, yes, is a particle. Yes, a proton is a particle, but a planet is considered a particle in physics as well. A baseball is considered a particle. It doesn't have to be small to be a particle. Some of you said, trying to watch the flow of the sheet, many of you said clever things like a particle is something that occupies space and time. Now, that is true, but that's not the whole story because anything that we study in physics occupies space and time. There are things in the world that are real, that are true, that there are things in reality that don't occupy space and time, or at least not in a measurable, observable, reproducible way. I believe justice exists in the world. We go to a college of criminal justice, or if you don't believe that, presumably you believe that injustice exists in the world, right? It's like a thing. We didn't make it's not just in my head or your head, and it's worth studying. People take, have whole majors in criminal justice or it's real. But injustice does not occupy space and time in a measurable, observable, reproducible way. A measurable, reproducible, predictable way. Anything that we study in physics occupies space and time. And you might want to write this down. Anything that we study in physics occupies space and time in a measurable, reproducible, predictable way. In fact, that's what it means to study physics, is to study entities that occupy space and time in a measurable, reproducible, predictable way. Now, particles do fit that description, but particles are not the only thing that fits that description. What it means to be a particle, is it means to be an entity that is particular. To be a particle means to be massive, material, tangible, identifiable, distinguishable, separatable, countable from other objects. To be a particle is to be a thing that is so thingy, that is so thingish, that it cannot do task number 3 or task number 5. Let me say this again. We have 10 more minutes. Again, I'm saying something that may almost sound obvious now, but if you're really listening to me, you'll realize I'm saying something that's not quite as obvious. I'm saying a particle is a thing, a thingy thing, a thing that is so thingy that it cannot perform task 3 or task 5. It's not just that it occupies space and time. To be a particle, it's not good enough that it occupies space and time. It's not even good enough that it occupies space and time in a measurable, reproducible, or predictable way. If something is a particle, it occupies space and time. And again, please write this down because I'm just talking now. I mean, this is real, but I'm not writing it. To be a particle is to occupy space and time in a measurable, predictable, a measurable, reproducible, predictable way, and yet not be able to perform task 3 or task 5. A particle is something that cannot be in the same space point at the same time point as another particle and cannot be in two space points at the same time point. That is what a particle is. But the reason I'm making a huge deal of it, again, you might think you knew all of that. I mean, you probably did know all of that. The reason I'm making a big deal of it is I submit to you that not everything in the physical world is a particle. Not everything that we study in physics is a particle. Not everything. There are things in the physical world. There are things in reality that occupy space and time in a measurable, reproducible, predictable way that can do task 3 and can do task 5. There are things that are not as thingy as particles. They're real, they're the subject of science and physics, but they can be in two places at once or share a space with another like thing. Can anybody give me a quick, I'm going to say that one more time. I mean, yeah, wait, we have 8 minutes. I'm going to write that down and then I'm going to ask you because that's the point of this class. Wait, hold on. Okay. Right? To be a particle is to occupy space in a measurable, predictable, reproducible way, but yet not be able to do task 3 or task 5. But what I'm submitting, so that's like summary number 1. But what I'm submitting to you is so there are entities. There are entities that are real. Okay, I'm not talking about ghosts. There are entities that are scientifically studyable that totally can share space with another similar entity and totally can be in two spaces at once. In other words, this whole thing of you can't be in two places at once or you can't share a spot with another thing, that's what it means to be matter, in effect, right? That's what it means to be particular. but that's not what it means to exist. So give me a quick, we have 5 minutes left. Maybe somebody new, maybe in the chat, maybe in private. In fact, let me even say, definitely say in the chat, please. And I'm even going to say in the private chat so that nobody can be influenced. I'm going to give you a minute. Please, in the private chat, try. In the private chat, please try. And I won't embarrass anybody, whatever. I certainly won't try to. I'll try not, whatever. Please, in the private chat, provide an example of something that actually exists in like the real world, in the scientifically studyable world, something that actually can share a spot with something else like it and or can be in two spots at once. And I'll give you a hint. Again, it's things that matter, but aren't necessarily matter. Can you give me an example in the private chat? And we have 4 minutes in the private chat. Oh, that's very clever. Somebody wrote antimatter, which is, first of all, totally proves that they're hearing my question, which is awesome and is very like advanced and sophisticated. I love it. Someone wrote antimatter, but I want to say it's like less sophisticated than that, like even more like basic. Um, oh, ooh. And someone wrote shadow, which is very cool and interesting, but it's not even that interesting. I mean, well, actually, shadow. Okay, shadow's on the right. Shadow's like the inverse of something that is actually what I am. I mean, shadow is the absence of a thing that I think actually would. I mean, I guess shadow is correct. That's interesting, but you can make it even easier by flipping the idea of shadow. And also, yes, exactly, person who just flipped the shadow. Yes. And someone else said water, which I want to say is also really good. I don't know if we literally mean water, like liquid, like liquids can't literally be in the same place at the same time as other liquids. I mean, it sort of feels like they can. They mix and stuff, but like each molecule that the liquid is, but you know they can't literally because when you pour more liquid, when you pour liquid into liquid that's already there, it takes up more space, right? It doesn't literally just get absorbed if you think about it. And even gases, by the way, I know we have 2 minutes, even gases, you seems like they could do that, but you blow into a balloon, the balloon expands. So they're going somewhere. But the thing why it's really clever that someone said water. So I'm just going to say right now, since we have 2 minutes, because I've now gotten it. I wouldn't say the water itself, but I would certainly say the waves in the water do this, right? Just like sound waves do this. And write this, we have 2 minutes, just write this list down. Sorry. Water waves, or even waves on a string, like even one-dimensional wave. Sound waves, electrical fields, electrical currents, magnetic fields, also gravitational fields, but I'll leave that for the moment. And electromagnetic radiation, otherwise known as light. Now, this all maybe sound very obscure, but with 1 minute left, let me just remind just someone right now, anybody, even if it's the same person, just right now for 1 minute, while I'm talking, just talk right now. Just turn on your microphone and make a noise while I'm talking, just for 1 second, like interrupt me. Talk right now. Someone just say something. I'm not even looking who you are. Just say something while I'm talking. Just anybody for 1 second. Just say something while I'm talking. Don't wait for me to stop. Just say something. I'm going to keep talking. Just
Hello,
say that.
hello.
There you go. Thank you. Perfect. Okay. The fact that she just did that, I know we have 1 minute, but if you heard Annie talking at the same time I was talking, or if you've ever listened to music, if you've ever heard a chord, if you've ever heard a singer and a guitar at the same time, it wasn't an accident. It wasn't a freakish detail. It's the nature of sound. Two sounds can be in your ear at the same time, right? And that's not a metaphor. And it's not a detail. It's the nature of same thing with light. If you've ever worked in a theater, you shine a red light down on the stage, you shine a blue light down. The blue light doesn't kick the red light out. I'm not joking. And it's not a technical point. The real nature of waves and fields and radiations, it's 420, is that they exist. They are real. They occupy space and time, but they share space and time and they spread in space and time. They are not particles, but they are real. And they are the purpose of this course. And everything in this course that we ultimately study is not I know it's 420, Physics 203 was the trajectories of particles. Physics 204 is the flow of information. All of those things, sound waves, water waves, electrical fields, they are all information. They matter, but they aren't matter. And they all exist due to the nature of oscillation. The reason we are getting so abstract about oscillation is that oscillation is the key ingredient to forming entities that exist in the real world, but are not thingy. Physics 204 is about unthingy things. Sound waves, string waves, electrical fields, electrical currents, magnetic fields, and electromagnetic radiation light. That's what this course is about. And the reason the math gets abstract is because the things are abstract. Okay, thank you for paying attention. Oh, light. Yes, light. Yeah, light. Totally. Yes, thank you. Okay, have a great, I'll see you in 2 days, right? Or hang out for any quick questions. But thank you. Have a good day. Yes.
Bye, thank you.
Thank you.
That was, yeah, it was, yeah.